if fx and gx, I take two functions as fx and gx, be two functions which are continuous in the given interval. First of all, these two are defined in that interval. Then their sum, difference, product and quotient will also be continuous. Left hand limit will be equal to right hand limit, that is equal to value of the function at the given point. Now left hand limit, right hand limit will be equal in this case, since the function is algebraic form. Also after simplification we get polynomial function. Here I have first written the condition of continuity of the function fx at x equal to a. Already according to the discussion I made, the condition of continuity is left hand limit, right hand limit and value of the function at the point x equal to a. Left hand limit of the function fx as x tends to a minus, already you know that will be equal to right hand limit of the function fx as x tends to a, that is x tends to a plus, that will be equal to f. Now continuity of the function fx, of the function say fx in the interval this, then what will be the condition? Actually the function fx will be continuous throughout this interval if it is continuous at every point in this interval, also that is continuous at the end points, that means at x equal to a and x equal to b. Now what will be the condition of continuity for the left end? That condition will be continuous at left end if L, if A is equal to R F A. Since the function is not defined here for the values which are less than a, therefore the function will be continuous at the left end when value of the function will be equal to right hand limit of the function as x tends to a. Try to understand. Fx is not defined for the values which are less than a. Therefore, for the continuity of the function fx at the left end of this interval is this, and for the right end here I can say left end, that is x equal to a, right end, that is x equal to b, if the value of the function at the point x equal to b equal to left hand limit of the function as x tends to e. Since we don't know the value of the function fx for the values which are greater than b, therefore for the two endpoints the condition of continuity will be these two. Next, and for all other points within a and b, the function fx is continuous. Next thing, algebra of continuity. If fx and gx, I take two functions as fx and gx, be two functions which are continuous in the given interval. First of all, these two are defined in that interval. Then their sum, difference, product and quotient will also be continuous. Let be defined and continuous at say x equal to a. We are discussing here at a certain point say x equal to a. Then sum of the function. Here I have omitted x, or difference of the function. Then product of the function. Then quotient of the function. Here the restriction is GA not equal to 0. These will also be continuous at x equal to a. A plus g means fx plus gx will be continuous at x equal to a. Fx minus gx also you can consider gx minus fx difference will also be continuous. Then fx into gx, then fx by gx. These functions will also be continuous at the point x equal to a. Thus, I have discussed the continuity of a given function at a point, then at a given closed interval, rather, this is closed interval, then algebra of continuity of two functions. Also, this will be applied for more functions, two or more functions. Then we shall discuss few examples on continuity. First term I have taken a function fx is defined as this. Then we have to check whether fx is continuous at x equal to 3. For that, first I mention the condition. Fx will be continuous at x equal to 3 if L F3 equal to R F3 is equal to F3. left hand limit will be equal to right hand limit, that is equal to value of the function at the given point. Now left hand limit, right hand limit will be equal in this case, since the function is algebraic form. Also after simplification we get polynomial function taking x not equal to 3. For that we find first the limiting value. Limit x tends to 3 fx, that is equal to limit x tends to 3 fx, means since x tends to 3, that means x is not equal to 3. That is why for fx we have to replace this one. Now we calculate the limiting value as learned in class 11. First we simplify the numerator or write the factor form of the numerator. Now you know x tends to 3, that means x is not equal to 3. Therefore we can cancel x minus 3 from numerator and denominator, since x is not equal to 3. Remember, we have to mention this one. That means that is equal to limit x tends to 3 x plus 3. After that we have to put the value, limiting value of the independent variable, that is equal to 6. Now f3 given f3 equal to 6, therefore limit x tends to 3 fx, both values are same, is equal to f3. Therefore the conclusion will be fx is continuous at x equal to 3. Follow my students. Better you first mention the condition of continuity at the given point. Here I have mentioned that fx will be continuous at the point x equal to 3 if limiting value, that means left hand limit, right hand limit, both will be equal and each of them will be equal to the value of the function at x equal to 3. Since it is algebraic form, after simplification you see, for x not equal to 3 we can cancel, we get polynomial function, and it is discussed earlier that polynomial function is continuous everywhere, that means for any real value of the independent variable. Therefore we calculate here the limiting value of fx as x tends to 3, we get the value 6, and as per this condition that should be equal to f3, also f3 as per definition is 6. Therefore both values are equal, therefore we say fx is continuous at x equal to 3. Now this problem, the function fx is defined like this. When x not equal to 0, this is sin 2x by 2x, and when x equal to 0, value of fx is k. Now to be continuous, fx will be continuous. For that we have to find the value of k. We follow the initial part same. Fx will be continuous at x equal to 0 if limit x tends to 0 fx be equal to x0. Now we calculate this one first, and you note that we are not calculating separately left hand limit and right hand limit as x tends to 0. Since x is not equal to 0, that means if x tends to 0 plus and x tends to 0 minus, then in both cases value of the function will be same, or we can replace fx by this same expression. That is why we are calculating directly limit x tends to 0 fx. Now limit x tends to 0 fx is equal to limit x tends to 0 sine 2x by 2x, that is equal to limit 2x tends to 0. Since x tends to 0, therefore 2x will also be 10 to 0. That is similar to the standard limit x tends to 0, limit x tends to 0 sin x by x equal to 1, therefore limiting value is 1. And if 0 equal to k, hence fx will be continuous at x equal to 0 if 1 equal to k, that means k equal to 1. Now if we work out sums, you see, I think already you have noted, we have to follow the similar reason, similar steps, and in most cases you see we have to find the limiting value of the function at the given point or near to the given point. Therefore, I mentioned that continuity is deeply connected with limits. That is why I mentioned.